Welcome back, everybody. So this is this will be the last video here, and we're going to go over a little more complicated example of how to use similarity to solve for the variables within triangles that we know are similar. And I'll try to walk us through this. Okay, so in this example, I already pre-drew it, so you don't have to watch me try to draw triangles. We have triangle DUG is similar to triangle ART, so Doug and Art. Okay, so this is what we're going to refer to. And you'll notice these triangles are not necessarily oriented the same way, and they're also not necessarily drawn to scale, okay? You can't always rely on things being drawn to scale. So you'll notice that as we go through this. So we're going to solve for x. We're going to be asked find x. And we're also going to be asked to find the length of AR, okay? So those are two things we're looking for, okay? Now, we identify our variable over here. Okay, and it's part of AR. So we're going to find x first, more than likely, and then solve for AR. Okay, so let's go ahead and make a proportion. Now, there's multiple ways of doing this. You can set this up a number of ways. What I like to do is identify a triangle. Okay, so I know that DU is here, right? And DU will match up with AR. So AR is here. So that's where these are going to be going on. So we're going to definitely be using 12. Now we have some options here. We have two sides here and two sides here. We can really use either one of these two pairings. It doesn't really matter. Let's look at AT. So AT is these two, the first and last letter. That means the first and last over here are D and G. So AT would actually match up with D and G. So 20 and 5. So this is obviously the larger triangle because 20 is obviously larger than 5. So I'm going to go ahead and label this big. There's a reason why I do this when I'm starting this out. It helps me make sure that the proportion I write is accurate. I'm going to have big over small here as I'm doing this. Hopefully this makes sense. Now I'm just deciding to do it this way. So that'll help me when I write my proportion. So we'll go ahead and start writing this proportion out. So I'm going to go ahead and use AT and DG. So DG is the first letter, last letter. So DG, okay, will be over the first and last letter here, which is A and T. So AT is 5. So AT. Okay, now we know that we're looking for AR. That's going to be on the bottom because it's a small one. So which one matches up with AR? The first two letters, which is D and U. So DU and AR. So we know that the relationship between these two sides is the same as this because the two triangles are similar. Okay, now we can go ahead and plug these numbers in. So DG is going to be 16. No, it's not 16. I apologize. 20. So 20 for DG. AT is going to be 5. DU is 12. And AR is x plus 1. Okay, now we're going to go ahead and solve this. I like to simplify this. So what's 20 over 5? That's 4. I might have to rewrite this over here. Let's see. And 12 over x plus 1. We have our variable in the denominator. No big deal, right? We can multiply both sides by this binomial here on the bottom. So x plus 1, right? Both sides. So I am going to cheat. I'm going to write it up here. So I'm going to go ahead and keep that as x plus 1 times 4. And it's going to go ahead over here, multiply here. These will cancel out. I have 12 on this side. And, oh, man, this looks so weird, doesn't it? I'm distributing from that side. I apologize. We'll survive, right? 4 times x is 4x. 4 times 1 is 4. Now this is really just a matter of solving this equation, right? So what do we do first? We're going to get rid of our coefficient or our constant. At home, constant, you got it. It's just easier to do it that way, isn't it? So we're going to do the inverse operation. Inverse operation of addition is subtraction. We subtract, boom. 12 take away 4 is going to be 8. 4x equals 8. Let's get rid of that coefficient. Divide both sides by our coefficient, right? 4. We're using inverse operation. You want to get fancy. Let's cancel. And then 8 over 4 is, of course, 2. So x is equal to 2. So we found our first target here. X is 2. Now, we want to know what AR is. Well, AR is x plus 1, right? So x plus 1. That's an expression here. Let's plug in our 2 here. So 2 plus 1 is what? You got it. AR is equal to 3. Now let's make sure this thing works. Okay, so we did all this work here. We found the two things we're looking for. Let's make sure this works. Now, DG, we know it matches up with AT, right? And if you look at this, there's a relationship. Look, this is 4 times the size of that, which means this is 1/4 the size of that, which means our scale factor from this triangle to that triangle would be 1/4 scale factor. Okay, so that means that AR, right, should be 1/4 the size of DU. So DU is 12, 1/4 of 12 is 3. Hey, it worked. Look at that. Right, so once you get really comfortable with these, it becomes a lot easier. I know this could probably be a little intimidating, but the more practice you get, I think the more sense it'll make. So anyway, please let us know. So let me know, let your math teacher know, ask us questions about this. We're more than happy to help. But I think definitely the more practice you get, the more sense it'll make. So hopefully this was helpful, and I'll see you guys soon. Bye-bye.